solve the system by the elimination method. Here we have the equations. 4x plus 5y is equal to 2, and negative 8x minus 10y is equal to 6. Well, in using the elimination method, we'd like to be able to add these equations together and get either the x or y variable to cancel out. So let's say we choose to eliminate the x variable. We have a negative 8x term in equation number 2, and let's identify these as equations numbers 1 and 2 for ease. If we multiply equation 1 entirely through by a positive 2, that will create a coefficient out in front of a positive 8 and allow those two to cancel out. So let's do that for equation 1. 2 times the 4x is 8x, plus 2 times that 5y is 10y, and that's equal to 2 times 2, or 4, on the right-hand side. I'm going to go ahead and call that equation 3 since we've changed equation 1 slightly. Equation 2 is negative 8x minus 10y is equal to 6. And you might notice something sort of unique here. As we add these two equations, the x variables cancel, but also the y variable cancels as well, leaving us with 0 on the left-hand side, set equal to 10 on the right-hand side, and that statement is false. When this occurs in using the elimination method, or the substitution method for that matter, when both of our variables disappear and we are left with a false statement, this indicates we've got graphically lines that are parallel, they don't intersect, and therefore there is no solution to this system. Let's summarize by saying that the solution set is the empty set. You might also say it's the null set, meaning that there is no solution to this system.